Today now in our class we are going to learn the queue concepts. So what is a queue? A queue we call as a first in, first out operation, which means that the data which is inserted first will be removed last. Data which we have to enter first will be removed removed at first. It is like a queue system where you are going to stand, where you are going to take a tickets for your cinemas. So when you are going to take a tickets for a cinemas, who comes first, they are going to get the ticket. Who comes last, they are going to get the ticket at the last. That is what we call a queue operation. Queue concept. So basically, when you are going to work on a queue is a linear data structure. Queue is a linear data structure where we are going to perform different operations on a queue, or we can say a queue is an ordered collection of items where the addition of new item and removal of new existing item takes place at different ends. So addition of queue a new item and deletion of an existing item takes place at a different end. But what happened in a stack? The addition of a new item and removal of a new item, removal of existing item takes place at the same spot called as top. So, but in a queue, what happens here is whenever you are going to add a data, whenever you are going to add a data, you are going to use them, you are going to insert them through rare. You insert them through a rare. To delete, you use front. To delete, you are going to use front. So first, it is for this reason we call this as a first in, means data is entered through front, through rear and removed from front. Data will be entered through rear and removed from front. That is for this reason we call that as a first in first out operation, or it is the ordered collection of item where addition of a new item and removal of the existing item takes place in different part. That is what we call a so that takes place at the different end. That is known as first in, first out operation. That is known as first in, first out operation. We can also call when an element is inserted at one end called as rear and an existing element is removed from other end called as front. It may okay. Here we always say the operation is FIFO means first in, first out operation. So the queue also perform different operations. First one is to start the queue, or to create a queue. create the queue we use we use a operation called as create. We use an operation called as create or queue. This is the operation which is used to create a data or create a linear ordered collection of a queue. Okay. Next, the second operation is enqueue. Enqueue. For what the enqueue is being used? This enqueue is used to insert the data to the queue. Insert the data to the queue. Okay, which means that it acts as a push operation. It acts as a push operation. Okay, so now, but before talking to this, let us see the program also. Together, let us work on this sum. Okay, first, what we are going to add the same here. First, we are going to define a size of the queue. Okay, using a queue size is equals to 5. Of top, we have the linker section. After that, class queue, we are going to create a class queue. Okay, which has the data members called as queue of array and front, rear, and count. Front is the used for to have a last data wherever data is, wherever we want to remove data. Rear is the thing wherever we want to add data, and count is used to keep track of that data. Okay. Next, queue is we have created a constructor at starting at the start at the start at the start your queue start of your queue at the start of your queue the both front and rear front and rear will be both front and rear will be equals to minus both front and rear will be equals to minus 1. Both front and rear will be equal to minus 1. Okay. So how a queue looks actually? Okay. So how a queue looks actually? A queue looks in a this is how a queue looks. Okay. So what happens here is here both front and rear both front and rear will be in a negative -1 position itself. Front and rear will be in a -1 position itself. Okay, this is front or we can call as rear which is equals to -1 and front is equals to -1. Okay, front is also equals to -1. Okay, so the first what happens here is here whenever your queue starts, both front and rear will be in a -1 fashion. Okay, this is how we are going to first thing what happens in this part in a constructor. Whenever your queue class queue hits right at the time, your front and rear will be initialized to -1. And here void enqueue of int x, we have a one declaration or one function called as enqueue, operation called as enqueue, other operation called as dequeue to removal, and third one is display. Now let us talk with the first operation called as enqueue. Here what happens when we say, wait a second, okay, so when when your rear, say for the example, when rear is actually it is -1, when rear double equals to q underscore size -1, which means that rear is -1 double equals to q size. We have defined our q size as 5 as 5 -1, which is equals to 4. 4. 5 -1 is equals to 4. When your q size is 4 -1 rare, if you can say, you can join if also. If if a rare is double equals to q size -1, if rare double equals q size -1, then we should say, for example, it will be done means when 4 double equals to 4. When you have a condition like 4 double equals to 4 means your rare reaches 4 and your max size is also 4. At that time, we say Q is full. Q is full. At that time, we can say that our Q, the size of the Q is full. You can say that the size of a Q is full. Okay? It says the size of the Q is full. Now what happens? Now this statement is false. So what you should do? So you should say that, you should check that if front it is false, then what you should do? Now you should check if front double equals to -1. Andre, the previously of front already we have initialized to -1. So -1 double equals to -1. It is satisfied, says that it is true. So what we should do? So now your front is equals to, should set front is equal to 0 and your rear is equals to 0. So what happens here? Your front will point to, your front will point to 0. Wait, I'll show you. 1, 2, 3, 1, 2, 3, and 4. Okay, this is the size of this is an array. Okay, 0, 1, 2, 3, 4. Now what happens here is Wait a second, I'll show you properly. Wait a second. Okay. Now what happens here is, here your rare is becomes 0, means your rare counter will be in this part. Rare counter will be in this part. And front counter also will be in this part. This is front, and this will be your rear. Okay. When your front is 0 and rear is 0, what happens? Your rear counter will point the 0th position and front counter also will point the 0th position. After that, what happens? After that, again, uh, again it is for now what happens here is, now your rear increments. Okay. Now here you see, first what happens, if rear double equals to q size, it is true, it is what we say, it is false. So what happens, it comes out of the loop and again it checks here. But here what happens, front double equals -1, it is true. Like for what happens here rear and front will be set to 0. Now it moves to else block of the if statement. Rear gets incremented. Okay, rear gets incremented. Here what happens, here q of rear, q okay, here this part I'm explaining this part now, so q of rear means rear is 0, q of rear is equals to x as an item, you can take as 20. Okay, so what happens here, 20 will be inserted here. 20 will be inserted here. Okay, next what happens, next again it is going to check here itself. Now your rear is 0. 0 double equals to 4. Again it is false. Now again it checks your front will be in the position itself. Now front is 0. 0 double equals -1. Again it is false. What happens now, your rear increments. Previously your rear was 0. Now rear increments and rear becomes 1. Okay, now what happens now? Now this counter moves to the first position. Okay, now here q of 1 is equal to some value. Q of 1 is equal to some value called as 30. Okay, which means that 30 will be entered here. Okay, next again what happens, again it checks for the condition 1 double equals to 4. Again it is false. What happens, it comes out of loop. Again it is going to check 0 double equals to 1. It is also false. So what it will do, it will go to the else block. Here q of rear gets incremented. Previously rear was 2, now rear becomes 3. 1 plus 2, 1 plus 1 is 2. Rare was 2. Okay. Now Q of 2. Q of 2 is equals to item called as 40. Okay. Q of 2 is equals to item called as 40. Again, so 40 will be inserted here. 40 will be inserted here. Again, what happens? Again, it will check that 2 double equals to 4. Again, it is false. Again, 0 double equals to 4. Also, it is false. Now, what happens? It comes to else block. The rare becomes 3. 3. Rare becomes 3. So, Q of 3. Q of 3. Some items you are going to enter as 50. So what happens here? Your rare moves to this part. But remember, front always will be there here. Front will be in that position itself. Front will be in that position itself. Your item as 50 will be inside out here. Again, it will check 3. 3 double equals to 4. Again, it is false. 0 double equals to -1. Again, it is false. What happens? It moves to next position and rare becomes 4. So your counter will move to this part. The counter will move to this part. So Q of 4. 4 is equals to 60. So what happens? 60 will be entered inside this. So what happened here? The rear part moved, but front part removed, weighted there itself, then there itself. Now what happens? Your Q increments. Now this increments as 4. 4 double equals to 4. It will be false. So what it will say? It's going to say that it is going to say that the Q is full. The Q is full. Say that the Q is full. Okay. This is how your Enqueue operation works. How your Enqueue operation works means first what it will do, it will check whether queue size is full. If the queue size is full, then it is going to have a print that the queue size is full and it returns back. Again, what it will do, it will check that whether your front is in -1 position. If front is in -1 position, then it will set the front and rear to 0, or if front is not in a -1 position, it will come out of the loop and it is going to do this work. It is going to do this work. So here how this works means rare increments, your rare counter moves until the value is been reached, the rare counter moves. Then okay, rare counter moves. Then the items is been added to the list. The items will be will be added to the list. Again, void queue. Now this is how a Enqueue works. Remember, this is how a Enqueue works. Okay. Now, how does the dequeue work? That you should see how does the dequeue work. Okay. So here what happens now? Here, first it will going to check rare front double equals to front double equals to -1. Okay, it is going to check front double equals -1, which means that -1 double equals to -1, which means that your queue is empty. When this line reaches, at the time we say that your queue is empty. Okay, which means that now what is the value of queue? 0 double equals to -1. It is false, right? 0 double equals -1. It is false. Okay, 0 double equals -1. It is false. So now what happens? Here now what happens means here it is going to see that now this works. Now what happens, it is going to keep a value called as x. Okay, you're going to keep a value called as x, okay, in a memory. and what happens, it is going to remove the data. Remove the data. It is going to remove the data. So what happens now means, here it will go have a pointer that rare is 4. Okay, rare is 4. 0 double equals to 4. It is false. So what happens here is q increments. First, it is going to remove the data first. What happens here? The 20 will be removed. 20 will be removed, and it is going to put into in this part 20. You're going to put that part into 20, and uh, here what happens here is front increments. Front increment means this front line moves to this part. Okay, the 0th position has been decremented. So count previously was 4. Okay, now what happens here is, here when a front increments, your count decreases. When a front increment, the count decreases to 3. Okay, again what happens, again it is going to say that it checks that your front, now front is 1. 1 double equals to -1. Again it is false. It comes out of the loop, and it is going to say that the value in a 1 will be printed out called as 30, and q increments. So q increments means this is going to remove, and then q gets increments, or if a front get incremented, and count becomes 2. Okay, now what happens, your front is 2 and your count will be 2. Now again it is going to check 2 double equals to -1. Again it is false. Okay, again it is false. Here also it is going to check 1 double equals 4. Again it is false. So what happens now? Now your front gets incremented. Front previously was 2, now becomes 3, and your count decrements. Count will be 2, now becomes 1. Okay, now what happens here is this x 40 will be removed. Your front will be incremented to 3. Front will be incremented to 3, and it is going to print value 40. Again what happens, again it is going to check as 3 double equals to -1. Again it is false. So what happens now, again your front increments. Your front, before incrementing the front, the value 50 will be added to the x, and your front this data will be removed out of here, and your front increments. Previously front was 3, now front becomes 4. Front becomes 4. Again it is going to check as 4 double equals -1. Again it is false. So what it is going to check now, again it is going to remove this value 60 to the block, remove this value 60 to the block, and this 60 will be removed out of here. Now it is going to check 4 double equals to 4. What happens, it will satisfy, it becomes true. It becomes true, and what happens, your front value will be equal to -1, and your rear value also will be equal to -1. Front value also will be equal to -1, and rear value also will be equals to -1, which means that the q condition satisfies. So what happens now, your rear also becomes -1, and your front also becomes -1. Your rear also becomes -1, and front also becomes -1. Then it is going to check again. It is going to say -1 double equals to -1. It is true. It says that q is empty. It says that your q is empty. This is how your q function works. Then display means it is used to display the data. The front and rear, it is going to check the front and rear, and then it is going to display the data. Same as your stack function. And empty, here queue of choice, as again it is the same as how I have explained for a stack itself. It is going to give the what we say, give the list what the user requests, for what for what the for what the user request is going to provide you the data, and then here it is going to use this and it is going to end the data. So here in the main function, what we are going to do, we are going to create a class followed by object name has the choice. This will be the same for as same as your stack operation, but the operations are enqueue, dequeue, print, and exit. This is the program for a queue structure, queue data type. So now let us see, let us use the C Turbo C++ to check for the output. Okay, Turbo C++ to check for the outputs. So enqueue. So I'm directly going to run this program. So hope you understood my explanation how this enqueue and dequeue works. So this is the program for a enqueue and dequeue. Okay. Now what I'm going to directly run my program. Function F9. Function F9. There is no errors. Control F9. Okay. Now what I will going to do, I'm going to enter the choice as 1, which means that I'm going to enter item 23. 20 is successfully inserted to queue. So let us print that data. Let us print that data. Okay. 3, which means queue contains 23. Again, what we are going to do, now I'm going to enter the data as 1 and say 34 should be entered. 34 is entered. Again 1, 45, 45. Again 1, 56. Again 1, 67. And again 1, if I do, it is going to say queue is full. Now let us print the queue 3. Okay, so what happened? Your queue contains some of the items. Okay, 23, 34, 45, 56, and 67, which means that the data entered from the rare part and it will rare part, and now rare, where is your rare? Your rare is in 67. Rare is in 67 position, which means that 0, 1, 2, 3, and 4. Your rare is in 4th position. Now I'm going to dequeue the data. 2. 23 is removed successfully, which means that the first element is been removed for directly. Now, if I print the data, what happened? 3. If I print the data, what happened? 34, 45, 56, and 67. Previously, your data was 23, 34, 45, 56, and 67. Watch out carefully. Again, I'm going to delete. 34 is deleted. 2, 45 is deleted successfully. Now, if I print, what happened? 56 and 67 is there. If I remove again, so 56 is removed. If I print it again, 67